Chapter 4 review. So we're going to, there's a couple of review assignments in the book that we will work through together. There's something you'd like to share with the class, Sky? Oh, thanks. We'll always love to hear that. Couple review assignments we'll work through together, and then I'll throw the practice test at y'all, and then we will take the actual test. Smart Money says maybe Wednesday or Thursday for a test. Okay? No, it doesn't really pick up students' voices at all. You have to be really close to the,
Hey,
yeah, maybe.
don't forget to do your homework.
All right, so here we go. Review number 1, figure 4-7A. This, by the way, BT dubs, as the cool kids say, is on page what? Oh, I don't know. It's at the end of chapter 4. I thought you had it all figured out, Cody. Let's see. Yeah, no kidding. Roasted in public. Okay, page 191. Page 191. All right, review problem number 1. Figure 4-7A shows the unit circle and an angle theta in standard position. Explain why u squared plus v squared equals 1. Let's choose someone to share their knowledge with us. Please, Gus. Please. I guess we're going to have a lot of absences today, huh? Okay, Janessa, how do you know in that diagram that u squared plus v squared equals 1? And what kind of triangle is that? No, not necessarily. Yeah, it's a right triangle. So who gets credit for that? Yeah, for that u squared plus v squared equals, thanks. U squared plus Pythagoras. Okay, so we know that is true because of the Pythagorean theorem. Okay? Like Janessa said, it's a right triangle, and 1 is the hypotenuse. Pythagorean. So the sum of the squares of the legs equals the square of the hypotenuse. Okay, then it says, hey, why does u equal cosine x and v equal sine of x? Gus?
Great.
Why is u equal to cosine and v equal to sine? Yeah, look at the little chart in front of the class there. What is the definition of cosine? And which one of these sides is adjacent? Nope, that's across from the angle. The angle is right here in this corner. U, yep. So cosine equals adjacent over hypotenuse, which in this case is u over 1, which is just plain old u. Yeah? Oh, okay. And then why is the sine of theta equal to v? Mm-hmm. Mm-hmm. And v over 1 simplifies to just plain old v. Yep, okay, good. Yeah. We've mostly talked about it in terms of x and y. Yeah. Yeah. Okay, so if you know u squared plus v squared equals 1, and you know u is equal to cosine and v is equal to sine, then y, Emelina, is cosine squared plus sine squared equals 1. What's that algebra called when you take something and you plug it into a different equation and then you... What's that? method of solving an equation where you're like, oh, I have 3x plus 7 equals 5, and I know x equals 2, so I'm going to... But Mr. Waver doesn't like us to say that, so then that's not true anyway. But so what's that fancy word for plugging it in? Okay. By substitution. Okay. All right, so we know that by substitution. So that was a little geometric / algebraic proof of the most important identity in the free world. Austin, let's show that this is true using numbers. Can you give me an angle? Yep, just give me an angle in between 0 and 90. 64, that's what I was going to say. Okay, so let's figure out what the cosine of 64 is. Do you have a calculator? Okay, that's all right. Oh, I was just trying to give an example to help Emily. So what's the cosine of 64 and what's the sine of 64? Yeah, and you're in degree mode. I checked it for you. 0.438. Okay, what's the sine of 64 degrees? 0.899. Okay, so will you go now? You're not off the hook yet. So will you tell me what 0.438 squared plus 0.899 squared is? Heck yeah. Yeah. For 0.438 squared plus 0.899 squared? So you just broke math. Okay, let's make sure you got the individual. No, it's all right. We'll figure it out. So cosine of 64, did you say 0.39 for cosine of 64? So do cosine 64 again. Maybe I didn't change it to radians. I mean degrees, sorry. Oh, I'm in radians. Ha ha ha. Okay. You were going to say that, Eric? Okay. And you're right. Okay, so 0.438, good, and then 0.899. All right, so then we need to just show that if we take each one of those and square them, 0.438 squared plus 0.899 squared. Yeah, so it's just so that's where you fell down on that one. If you square those, you get basically 1. It's a little bit bigger than 1 because we did some rounding. If we had not rounded it, we would have gotten 1. Yeah. Yeah, because you went times and we were doing plus. I want to do that squared plus that squared. Okay? All right, so this is the reason why sine squared plus cosine squared equals 1. Geometrically, this is an example of a way that it works. They want us to also show it graphically, but we are not going to do that. Okay? All right, so next one. Write equations expressing tangent of x and cotangent of x in terms of sine and cosine. Easy peasy, thanks to Elena. The answer is on the wall in front of you. El frente. Nope. Oh, Erica is here. Erica, how can you write tangent in terms of sine and cosine? Yes, ma'am. And how can you write cotangent in terms of sine and cosine? Awesome. All right, good deal. Write equations expressing tangent and cotangent in terms of secant and cosecant. Ooh. Yeah. All right, so Claire, write an equation expressing tangent in terms of secant and cosecant. Well, let's see. So we know tangent is sine over cosine, right? So I don't know if this is what they're getting at or not, but which one is sine with the cosecant and secant stuff? Okay, so if sine, I don't want to blow you guys away or anything, but if cosecant is 1 over sine, that means that sine equals 1 over cosecant, right? Okay, what does 1 over cosine equal, according to the chart? Secant. And so that means that another way that we could write tangent is we could write it as secant over cosecant. That's kind of wacky and wacky. If that's worth like remembering or writing down in a special place or what? I don't know. Okay, Sky, now that Claire did the heavy lifting, how can you write cotangent in terms of secant and cosecant? Yes, ma'am. Write cotangent in terms of secant and cosecant. Right? So the easy way to do it is, what is cotangent compared to... Yeah, good. Flip them. So I need to just flip this. Okay? So I could flip this over and make it be cosecant over secant. The Patriots did not play this weekend. They had a first round bye. Yep. Ravens lost to Chargers.
The Chargers should have had
I know they're 12 and 4 or something. And they're a wild card. That's crazy.
and not only were they, yeah,
I know, but I mean, that's the Chiefs, but yeah.
it was whichever team lost.
Right. No, I get that, but that's like they have to be one of the highest wild card.
I guess they have.
No, it's just the Seahawks got to go to the playoffs once with a losing record. They were 7 and 9, and they hosted a game. The Saints came to Seattle. That was the Beastquake game. So I mean, they just have rules, and just however it finishes out. Right. No, I get that. Well, right. You can't be a wild card winner and get a first round bye. Yeah. Correct. Okay. Right. Right.
So the four home teams
Are the division winners. Right. And so that's why when Seattle went to the playoffs at 7 and 9, they hosted a playoff game because they won their division. Yeah. And the Saints were a wild card, so they had to travel. They're pretty good on the road. You can throw them down. Okay, we also have 3 equations where we have squareds that equal 1. These should be in your notes. Okay? So Eric, give me one equation where the product of 2 trigonometric functions equals 1. Okay, that's not what I was thinking of. Anyway, so give me a trig equation. Multiply, yeah. What? Okay, but let's not, that's what I thought we were getting at, but this is saying products, not plus. So if you give me sine, what's the inverse of sine? Okay, so sine times 1 over cosecant equals 1. That's what that's what they're getting at. Does that make sense? Okay, give me another one. Cosine times 1 over secant equals 1, and then what's the last one? No, because that would be tangent times tangent, so then you'd end up with tangent squared. Right, so you could go tangent times, I think what they're looking for though is tangent times 1 over cotangent equals 1, because those are inverses of each other. You're right, you could do it that way. Eric, can you explain to Sky where you got those answers from? How'd you know that? Yeah, you go up to you just look at the poster, and whatever, if you multiply something by its inverse, then it's going to equal 1. So he was just looking up here and seeing that since cosecant is 1 over sine, that means if you multiply those together, you're going to get. I totally did that wrong. Yeah. Yeah, and it's been recorded for posterity's sake. They are inverses of each other, so I don't need to put 1 over them to multiply them together. Yeah. Son of a butternut squash. My apologies to all of you at home. Sine times cosecant is 1, because they are reciprocals of each other. You don't have to be. Right. I wrote this in pen, Mr. Aldrich. I hate you. Cosine times secant is 1. Tangent times cotangent is also 1. Well, at this point, she might actually call me a name. If she watches this. Is she going to watch it? She did. That's awesome. Not really, no. Sorry. You have to really be right next to it.
Sure.
Not 100%, no. You pick up some background noise, but not much. Okay, this one we're going to skip. All right, then for E, it says write equations expressing sine squared, tangent squared, and cosecant squared in terms of their friends. So we know that sine squared plus cosine squared equals 1. So, Mr. Aldrich,
I wrote it in pen.
how do I get that sine squared by itself? No, but yes. Subtract what? But we want sine squared to be equal to. So I'm actually going to. There you go. That a kid. Okay, now does anybody in their notes have one of the squared thingies for cotangent or tangent squared? That we can start with? Or I'm sorry, tangent squared or cosecant squared? Maybe. Oh yeah, no, we won't have the test tomorrow. Either tangent squared or cosecant squared. Maybe Wednesday, could be Thursday. One more time, I'm sorry. Tangent squared plus 1. Okay, perfect. Okay, so how do I solve that for tangent squared? Equals secant squared. Tangent squared plus 1 equals secant squared. I want to get the tangent squared by itself. Good. So for this one, all I have to do is subtract 1 from both sides. Okay, and then for the last one, I want cosecant squared in terms of cotangent. So what's my, Cody, what's my cosecant squared? Okay, so we're already done then with that one. 1 plus cotangent squared equals cosecant squared. So we have that. Okay? All right, then we haven't talked about this much, but it's come up in this chapter a couple times, so let's go ahead and just bite the bullet and deal with it. Get over it. So this next one, it says sketch the graph of the parent function of y equals cosine of x. So what do you know about cosine of x? The what? Oh, I guess I haven't really thought much about that yet. Okay, the period is 2 pi, good. So that means it's going to complete one cycle in between 0 and 2 pi. And so just for funnies, I'm going to make it go both directions. I said already, just for funnies. Okay, what else do we know about cosine? What else do we know about cosine? Yeah, it goes in between 1 and -1. All right. Whew. Okay, Cody, describe to me the graph. We got everything we need. Where does it start? Cosine starts at the top. Where does it go from there? Pi over 2, and then where? Okay, and then same thing. That's okay. I was trying to tell my friend a story on Friday, and I said pan of paint instead of can of paint. Like, what just happened? Okay, so that's cosine. Pan of paint. Like, what did I just say? And then I called my wife by my daughter's name. What is happening? My brain is just random. Alzheimer's, here we go. All right, so then secant, that means goes like this. Okay. So the orange is secant. All right. So apparently, Gus, it's important for you to know how those graphs relate to each other. Is the orange one? Okay. The mustache.
If you take Mr. Aldrich's beard away, that's the mustache. That's the
Okay, may I turn the page? All right, next one. So one of the main things that we did in this chapter is transformations. And I know that they were a little bit challenging, but that's okay. So they want us to take tangent of A times the sine of A plus the cosine of A and turn that into secant. So what is the first thing that you think we should do in order to accomplish that? Secant? What's one easy change that we can make to the... But it doesn't equal anything, so I'm not minusing. I'm using the identities. I'm using these things on this poster. Right, so we're trying to, so that's a good point. So we're trying to get this to secant. So I guess what Sky is saying is let's start on this side. So we want to show that this is equal to secant. She says, well, secant is 1 over cosine. So if we could get this stuff to be 1 over cosine, then we'd be good, right? What's an easy transformation that we can do with either tangent, sine, or cosine? Yeah, yeah, good. Tangent is sine over cosine. It's a pretty good strategy to start by changing everything into sine and cosine. Okay? So if I have sine over cosine times sine, what does that simplify to be? There you go. Sine squared over cosine. And then to make this a little bit easier to understand, I'm going to write the cosine as cosine over 1. So how do I go about adding two fractions together? What do I need to do? Yeah, to add two fractions together, I need to get a common denominator. What is my common denominator going to be in this case? Good. So this side already has a cosine A. So since I didn't change the bottom to get that, that means I don't have to change the top. This one over here, though, has a 1 on the bottom. So what do I have to do? I have to make that into cosine. Good. And so since I did that by multiplying the 1 by cosine, I have to multiply the top by cosine also. So that gives me cosine squared. Maybe some of you guys can see the light at the end of the tunnel at this point. What is sine squared? Is 1. So this really works out to be 1 over cosine. And that's what we want it to be equal to. So we are done there. 1 over cosine A equals 1 over cosine A. Does it? We used the fact that sine squared plus cosine squared equals 1 to put those together like that. All right, let's try another one. Okay, so this one wants us to go cosine b plus sine b squared. So what is cosine b plus sine b squared? How do you write that? What does squared mean? Right, so I'm going to write this twice. So I'm going to go cosine b plus sine b times cosine b plus sine b. I will. Well, you've had one for 4 days, so probably started when... All right, so now we need to FOIL this out. So Gus, what is the first thing times the first thing? Cosine times cosine. Okay. First times first is cosine squared. Then I need to go outside times outside. Cosine times, we're multiplying. Then I have to do inside times inside. They don't cancel because they're both positive. We'll get to that in just a second. Then what do I get when I go last times last? Sine squared b. Okay, so you guys see what he did? First outside, inside, last? Okay. Don't see it? Okay, the first thing in each parentheses was a cosine, so we multiplied those together and got cosine squared. And then the outside thing in each parentheses was cosine times sine. The inside thing in each parentheses was the same. And then the last thing in each parentheses, sine times sine, is sine squared. All right, so now we've got some simplifying that we could do from there. Austin, you see anything we can simplify? Uh-huh. What about it? What can I do with these two things? Yep, because they're both the same. So that's going to be 2 cosine b sine b. And then what have we tried to drill into your noggin for all eternity? That sine, yeah, cosine squared plus sine squared equals 1. And that's what they wanted us to get. So we are done. Okay. All of any right. Sine squared plus cosine squared is 1. Oh, no, because addition, it doesn't, right? 3 plus 2 plus 4 is the same as 4 plus 3 plus 2. Doesn't matter. So we switch them up. But you fixed yourself. You caught yourself before you said something stupid out loud and embarrassed yourself in front of the whole class. Nice job. All right, so let's do another one. This time let's go 1 over 1 plus sine c plus 1 over 1 minus sine c. And we're going to try and get it into that. Okay? So when you are adding fractions together, how do you go about getting a common denominator? Okay, so I got to put these two together. So I got to make this is going to be a big old denominator. I got to make this 1 plus sine of c times 1 minus sine of c. And I got to make this 1 plus sine of c times 1 minus sine of c. So what did I... Okay, we'll mess with that in a minute. What did I multiply this by to get this common denominator? 1 minus sine of c, so that's I have to multiply the top by also, right? Well, the top is just 1, yes. If I multiply that by 1 minus sine c, I just get 1 minus sine c. What do I have to, what did I multiply this by to get the 1 plus sine c, so I get 1 plus sine c on top. All right, so now that I have a common denominator, I can combine my like terms on the top of each fraction. What do I get when I combine 1 minus sine c plus 1 plus sine c? Nope. The signs will cancel. And 1 plus 1 is 2. And that's going to be over 1 plus sine c times 1 minus sine c. Okay? All right, now let's do the bottom. What's the first times first? We'll FOIL this out. What's first times first? 1. Outside? Close. Good. Negative sine of c. Inside? Good. Positive sine of c. And then we'll right, because those are going to cancel. Good call. And then sine times negative sine is negative sine squared. Yeah. Okay, then Austin said, and he's correct, we didn't really even have to write these out because these will just cancel. So it's 2 over 1 minus sine squared. What does 1 minus sine squared equal? Nice, cosine squared. So I can rewrite this as 2 over cosine squared. And 2 over cosine squared is the same as... Nice, because secant is 1 over cosine, so that means 2 over cosine is 2 secant. Okay? Woof. This is not easy, is it? It's not easy and it's not fun. It's the best of both worlds. But today's opposite day. Okay, we're going to try 2 more, D and E, and then we're going to call it.
Yeah, let's call it.
Not yet. Are you? Okay, so now we're going to do cosecant. This is number D. Cosecant D times cosecant D minus sine of D. We want that to equal cotangent squared. No. I made a mistake. Again. Yeah, this is actually, no. Well, you don't get to have a test on this because we're only halfway through the chapter, so all you get is a quiz on it. Disagree. All right, let's distribute the cosecant.
Objection.
Let's distribute, this one actually isn't that bad. Let's distribute the cosecant. What's cosecant times cosecant? Cosecant squared. What is cosecant times sine? What's cosecant times sine? You're on the right track. Nice. Cosecant and sine are inverses of each other, so that just works out to be 1. Okay? Then we have a squared identity with cosecant squared. What is cosecant? What's the cosecant squared identity that we know? You should have it in your notes. You have 3 squared identities, one with sine and cosine, one with cotangent and something. What's the one with cosecant squared? 1 plus cotangent squared equals what? Okay, thank you. So do you guys see how I can replace this cosecant with 1 plus cotangent? So it'll just equal cotangent squared, yeah. Because the ones cancel, and you just have cotangent. Okay? Alright, that wasn't so bad. Maybe we can do a couple more. Call it what? Okay, one more. Yeah, there's plenty more. There's always more. Siempre más. All right, last one. This one looks a little bit frightening. Because there's 3s and 5s and a 34 in here. That's why. Never seen numbers like that before. Okay, prove that this equation is an identity. 3 cosine E plus 5 sine E squared plus 5 cosine E minus 3 sine E squared equals 34. Are you ready?
That is my point right there. Well, I think it's definitely
You guys think the music
Wait,
features
isn't
her
it
next?
Margarita? Margarita. Oh.
You know you said music features the
Yes, yeah. I called it
Same. I went to it and he was like, we take photos right now. And they all like have to talk and I'd be like, Alright, so then.
what is this?
America. He goes, oh, you're making
These are squared, right? So squared means times itself. So 3 cosine E plus 5 sine E squared means, like Sky said, make it double. 3 cosine E plus 5 sine E times 3 cosine E plus 5 sine E. And then the other one is the same thing, but negative. Okay, it's all good. Huh? I noticed that too, yeah, in the last one we used, yeah, I noticed that too. Your observational skills will serve you well in the future, young Jedi. All right, so let's boil these bad boys. You ready? What's first times first? 9 cosine squared E. What is outside times outside? Well, but I've got a 3 here and I got a 5 there, eh, Mason? So 3 times 5 is 15. Good. So outside is going to be 15 cosine E sine E. What's inside times inside? Same thing. Good. Plus 15. I'll write them in the same order. Hopefully that'll make it easier. And then finally, what's last times last? 5's 25, dude, because we're multiplying. Okay, so that's the first set of parentheses. Yep. Now we're going to do the same thing with the second set. So 5 cosine E times, shh, almost there, shh, shh. That's going to be 25 cosine squared E. If I do outside together, what do I get?
5 cosine.
But I 15 cosine E sine E. I know I can't even fit it on my board. When I do the inside ones together, what do I also get? Same thing, 15 cosine E sine E. And then when I do last times last, positive 9 sine squared E. Okay, so that is a mess, but there is salvation waiting for us at the end of the road. We got a ton of canceling to do. 15 cosine E sine E cancels with negative 15 cosine E sine E. 15 cosine E sine E cancels with negative 15 cosine E sine E. How many sine squareds do I have altogether? I won't argue with you. I got 9 sine squareds right here. I got 25 sine squareds right there. How many do I have? 34. So I've got 34 sine squareds. Plus, how many cosine squareds do I have? 34 cosine squareds. So guess what? if sine squared plus cosine squared equals 1, what do you think 34 sine squared plus 34 cosine squared equals? 34, which is what we were trying to show. It is. All right?
That's my answer.